All right, we are adding polynomials and subtracting polynomials today. So there's two methods. I don't care what you do. I think the first method's a little bit faster. To add a polynomial, it's a group of terms, right? Here's one polynomial. Here's another. There's not much to it. It's really just like combining like terms. What makes it alike is the variable, the base, and the exponent have to be the same. All right, so we're just really adding like terms. So what does 4x to the third go with? Sav?
Negative 8x cubed.
Right, so I'm going to put one line for those two. X squared, does that go with anything? Sam, does negative 5x go with anything?
Yeah.
What does it go with? What? So I'm going to do two lines on that, or circle it, or square it, or triangle it. Sometimes I do this, double lines. And then negative 7, does that go with anything, Ari?
Positive 1.
So I'm going to do 3 lines on that. And then every time I combine something, I'm going to cross it out so I don't make a mistake, especially as these get really long. So 4x cubed and negative 8x squared. Let's start in the back row with Matthew. Oh, I gave Adam Matthews, didn't I? Sorry. Did you give it to him? Okay. Matthew, so 4x cubed and negative 8x cubed make what? Negative 4x cubed. I used it, I cross it out. Okay, and I'm always doing this in standard form from highest term to lowest term. Logan, you weren't here yesterday, so standard form is from the highest exponent to the lowest exponent. Okay, that's why I started with the 4x to the third. So the next one would be, what is x squared? It goes with nothing, so I just write it down. Okay, and now I'm going to go to 2 lines. Negative 5x, Logan, and negative 2x. What does that make?
Negative 7x.
Negative 7x. I'm crossing it out. I use that. What's left, Kendall? 1 and what else? Negative 7. Negative 7 and 1 is? Negative 6. And I cross them out. Now I make sure I've used all the terms. So that's method number 1. I really don't care what method you use. Notice my PowerPoint uses this. I used to actually do circles and squares. I used to kind of go, okay, I'm going to circle this. And then I do, 4x cubed. And then I go, okay, there's nothing that goes with that, so I'm not even going to square that. Plus x squared. And then I'm going to square, but I kind of like the lines better. You know what I mean? It's not as sloppy. And so you can do it however you want. And then method number 2 is the vertical method, where you put, so in the second, we write down the first polynomial, and then we line up, I'll go, negative 8x to the third lines up right here with 4x to the third. And then we're going to line up, I'm going to do it in blue. X squared, there's nothing that lines up. Negative 2x, and positive 1. So this is just a visual way that might be a little bit better for you. We're really adding the whole two together. So this is a positive and a negative. It makes negative 8x to the third. Oh, negative 4x, sorry. I bring down my plus x squared. We have negative 7x, and it's negative 6. So you can do it either way, horizontally, vertically. I think that horizontally it's a little bit faster. But I'm not going to care how you do it from this point on when you're combining like terms, whatever's best for you. All right, so let's talk about really quickly like terms and unlike terms. Remember, base and exponent have to be the same. So 5x and negative 4x are like terms, but 5x and y are not. 3m squared, negative 3m squared, and m squared are like terms, but negative 3x and 4 are not. I get a lot of people adding at the end and wanting to make that 7x. Okay? 7xy is the same thing as 2yx. Those are like terms because x is to the first power, y is to the first power. Order doesn't matter. Just like if I do 2 times 3 is the same as 3 times 2. Okay? But if I do negative 5xy and just 2y, remember, it has to be an xy to be a combination, a like term. 4/5 a and negative a, the coefficients can be different as long as the base is a and the exponent is to the first. That makes them like terms. 4x squared but negative 3x, we cannot add an x squared. That's like the price of a large drink and the price of a small. They're not, I'm not, if I'm doing 5 large and 3 small, I wouldn't put them in the same category. Okay? And then we've got 3x squared y or yx squared. Why is this a like term? Daniel?
The bases are the same.
The base are the same and the exponent the same. The order is changed. That's okay. But why is this not? Carmela?
Because the exponents are different.
The exponents are different. X is squared in the first one and y is squared in the second one. So do you understand? It has to be like exactly the same. The base and exponent have to be the same for it to be like terms. All right, let's jump down to, you want to try number 3? Why don't you guys go? Let's just do number 3.
Squared and negative y squared.
All right, so let's check our answer. 4y squared. I'm going to just go through here. Oh, didn't mean to do that. Whoops. Okay. So 4y squared, you said, goes with what?
With negative y squared.
Good, and that makes
3y squared.
3y squared. And then negative 3y.
Goes with 8y. And then that makes 5y.
Plus or minus.
Plus.
Okay, and am I done?
No. And then you have to do plus 7.
Plus 7, you got to bring it down even though it doesn't have a mate to be added with. Okay, questions? Okay, let's go on to the next one. Pretty simple. I don't care which method you're using. I'm going to give you one that's a little bit more difficult. I don't know that any of these are. Let's try the last one, number 6. Pause the recording. Okay. 6t to the 4th, Jordan.
What?
6t to the 4th goes with what?
Nothing.
Nothing. So I'm just bringing it down?
Yes. Yeah. So you bring that down.
Okay. So what about negative 8t to the 3rd?
You add that with t to the 3rd, which would become negative t to the 3rd.
Negative t to the 3rd?
Yes. Or negative 7t to the 3rd.
7t to the 3rd. And what about t squared?
T squared, you would add that with 6t to the squared. So
You know, this is very pretty. Everything's in order, like they're giving you these in standard form, but you're not always going to get it in standard form. Does that make sense? So they may shuffle them on a test, and then, you have to put them in standard form. Okay, 7t to the 3rd. Keep going.
So then, if you add t squared and 6t squared, you get positive 7t squared.
Good. And last.
And
Oh, not last.
you subtract t from 5t to get positive 4t,
Positive 4t.
and then negative 8 at the end.
Negative 8 at the end. So, 6t to the 4th. Can any of those be added? All right. We're moving on. So now let's apply it to some area problems. All right. So really, what am I doing? If I need to find the area of this irregular shape, how would we go about finding it? Ari.
You divide it into two shapes and then find the area and add it.
We add the two shapes together. So area of the big rectangle. So I'm doing the big, what's the formula for the big rectangle? Ari?
Length times width.
Big length times width plus the small length times width. Okay? So what am I multiplying together here? Want to go?
For the big one, 6
Shh.
times 2x plus 5
6 times 2x plus 5.
plus 3 times x plus 2.
Does everybody understand what we're doing here? Somebody said to me last period, where'd you get the 6? We're doing width times length. Width times length. The order doesn't really matter. So now we're distributing and we get, keep going.
12x plus 30
Good. Plus,
3x plus 6.
good. Like terms?
15x plus 36.
15x plus 36. Questions? Pause the recording and do number 2. Go. Kendall, what am I multiplying together? Or what am I doing here?
For the big one, you're going to multiply 7. You can just distribute it to
7 times.
7 times 6x to the second power plus 5x.
Good. And then,
And then for the small one,
what am I going to do with the small one?
you're going to
Add.
add it 5 times 3x to the second power minus 2x.
Good. And now we're going to distribute and we get
You get 42x to the second power plus 35
plus.
plus 15x to the second power plus 10x.
What?
Plus 10x. Minus 10x.
Minus 10x. Good. And now we're combining and we finish with, we combine our like terms and we finish with,
You add those two, and you get 57x to the second power, and then you subtract, and you get 25x.
plus 25x. Okay. Make sure you're putting that sign in. Don't just put the amount. Questions? Okay, so you're okay with shapes, right? Okay, this one, they love to do this with a piece of wood. They give you a question with a piece of wood, and they'll give you the parts. But really, they're already really just naming this. This is 4x squared minus 5x. And the other one, it says, is 3x squared minus 2x. And so what are we doing to find AC? Mr. Dawes? Right, so 4x squared minus 5x plus 3x squared minus 2x. We're adding the polynomials, and what do we get?
7x squared minus 7x.
What'd you say? 7x squared
Plus 7x.
plus 7x. Okay, questions? I'm going to skip the next one, and I think we should go on to the next lesson. Sometimes kids get a little freaked out with something like this. First of all, it's a trapezoid. So they look at it and they're like, oh my God, I can't do this. But one thing you have to remember is sometimes they just give you what you need. They're not asking you to find the dimensions because they're saying, find the area. But I have the area of all 3 parts. So what do we have to do? Just add them together. It's no big deal. It's not a hard problem. It just looks complicated. Do you have to do it this way? I showed you the vertical way, right? You don't have to. You can line it up. You don't have to, but you can. All right, subtracting polynomials. What is an additive inverse? Lauren, what's the additive inverse? Additive. Additive means adding, right? Adding the opposite, that's it. And it's right there. It's a little reminder. So, what is the opposite of y? Tell me, what is the opposite of y? Let's go with Arabella.
The opposite was
Negative y, good. What about the opposite of a binomial? The opposite of a binomial, yes.
Well, can't you use the distributive property and multiply by like negative?
Yeah, it's like we just take that negative and we're multiplying the whole binomial by a negative. We're taking the opposite of the binomial. So what does that give me?
Negative x minus 3.
Negative x minus 3. What would be the opposite, Sav?
Negative x plus 4.
Negative what?
Negative t plus 4.
Negative t plus 4. Now this is the work. Start with the negative, multiply it in. So when Miss Sophia says, show me the work, that's what we want to see. Malcolm, what would be the opposite of 3m squared minus 6?
Negative 3m squared plus 6.
Yep, just distributing it. Now, we could also turn that around and call it 6 minus 3m squared. Okay, next one, Chris. What is the opposite of 3 minus w?
Negative 3 plus W.
Negative 3 plus w, or
W plus W minus
w minus 3. Take the opposite, just move them around. Yes.
You said for that one in there, negative 3m squared plus 6, you said you could use 6 minus 3m squared, but wouldn't that not be in standard form?
You're right, but sometimes when we factor, we may want to turn it around. So this happens quite a bit. You'll see when we start, like, we're going to be doing giant fractions with polynomials. We're going to be adding them, subtracting them, multiplying them, and dividing them. And sometimes we're going to need to get this to be the opposite. So, oops, you can see just because I need it, you're right, when you have a fraction, you need the denominators to be the same. This is common to do this. Divide out, factor out a negative 1. Does that make sense? So, if I multiply it by a negative, it flips it around. And then the last one, let's go with Alexander.
for the last one, it would be negative x to the second power minus 5x.
Perfect. Is everybody clear on how to do these additive inverses? Okay, so now, opposite of a polynomial. We're going to get a polynomial and we're going to distribute it. That's it. Just distribute it to everything in there. So, what would the first one be? Let's go, Kaylin. Shaylin.
Negative x to the third minus 4x plus 9.
Plus 9. Anybody whose name I forget, you can come and collect a Jolly Rancher. I shouldn't record that, but I will do that, Kaylin, Shaylin. Sorry. Okay. Negative, what did you say it was? What did you say it was, Shaylin?
Negative x to the third plus minus 4x plus 9.
Good. Okay. Number 2, let's go with Alan.
Negative y to the fifth plus 2y to the third minus 7y.
Good. Next one, number 3. Okay, Mary.
Negative t to the fourth minus t cubed plus 9t plus 2.
Does everybody get the idea of what we're doing?
Yeah.
Do the last one. Go. All right, now check your work. Okay, so now we're going to take what we just did there and we are going to subtract polynomials. So step 1, we have to distribute that negative. That's the first thing we do in the middle. Before we had a plus sign, it doesn't matter if we distribute it. Everything's going to be the same if it's a positive in the middle. But when it's negative, it must be distributed. So negative, it's going to be a negative 2x and a negative 4. And then I bring down everything else. Now we combine like terms. And we have 8x squared are the same. And negative 5 is the same. And so what does it combine to, Chris? Chris Feichens.
6x squared minus 9.
Minus 9. Now, as soon as I teach you to factor, all you're going to want to do is factor that out. We're not factoring. We're just combining like terms. Okay, pause the recording and do 2 and 3. Go. Now let's check our work. Number 2, you should have distributed first, and you should have ended up with negative 10k squared minus k plus 1. Number 3, 6t squared minus 5t plus 13. Questions on either of those? All right, so this is basically it. Let's go to a couple of the... Here's an example of a word problem. I'm not really spending a lot of time. Mark has $50 and he owes 3 friends money. Jim $12, Carol $6, and Steve $10. We can write that as a polynomial and then distribute the negative. Or we can just use our order of operations. They both work out. Okay, hold on, guys. I'm trying to get to the end. Shh. Oh my gosh, they just go on forever subtracting and adding polynomials. So did everybody write down the homework? What'd you say? Okay, I'll tell you. Okay, so now look at this area problem. We're looking for the area of only the shaded area. In this case, what are we going to do? Logan.
You will subtract the smaller square from the bigger square.
Okay, exactly. We find area of the big, and the big is length times width, and we're going to subtract the small, length times width. And so really it's going to be 9 times what? Can I get a volunteer? Yes, Mary.
9 times 3x plus 7
Good.
minus 5 times the quantity of x plus 2.
Okay, then we're going to distribute. We get minus 5x minus 10, and it becomes 27x plus 63, and then we combine like terms. 27 minus 5 is 22. Oops, 22x. And now we're going to do 63 and negative 10 is 53, positive 53. Okay, questions? All right, now, you guys do the next one. What would I do there? Well, actually, I want to go over the homework a bit. And a bell's going to ring. Our bell did ring, so remember we're still taking area of the big minus area of the small. So, please listen. Shh.